How much do you know about the effects of alcohol during pregnancy? The reality may surprise you. Alcohol exposure while in the womb can damage the brain of the developing baby, causing it to develop fetal alcohol spectrum disorder, or FASD. It may lead to lifelong physical and/or neurodevelopmental impairments, such as problems with memory, attention, cause and effect reasoning, and difficulties in adapting to situations. For such an impactful disorder, it is rarely spoken about in the popular media. NOFASD Australia's podcast series is designed to raise awareness and understanding of FASD by giving listeners an opportunity to hear from those who have the deepest understanding of the impacts of FASD. This is Pregnancy, Alcohol and FASD, the surprising reality.
Welcome, everybody, to this episode of Pregnancy, Alcohol, and FASD, the surprising reality. I'm your host, the friendly neighborhood podcaster, Kurt Lewis. Today, I am joined by a couple of amazing guests. One is a leading researcher on FASD for over 20 years, a NOFASD ambassador, and has been a professor at the University of Minnesota since 1996, Professor Jeffrey Wozniak, or Dr. Jeffrey Wozniak, if I'm being more correct. My next guest is a pediatric neuropsychologist, a researcher, an assistant clinical professor at Nationwide Children's Hospital and the Oklahoma State University, Dr. Blake Gimbel. How's it going, Jeff? How's it going, Blake?
Fantastic. Great to be here with you, Kurt, today. I'm looking forward to the conversation.
Yeah, great to be here, Kurt. Thank you so much for inviting us on.
Thank you for both for coming. I'm excited to both have you really great researchers here right now, and I've got a lot of questions for you, so I hope you're prepared. You both get my list of questions, so I hope you weren't feeling too overwhelmed by them all.
We're always prepared.
Both of you are in the field of pediatric neuropsychology. What made you want to focus your research on fetal alcohol spectrum disorder? I'm just going to ask this question to you, Jeff, before taking it to Blake, if that's okay.
Sure. Yeah, happy to answer this question. I first became aware of fetal alcohol spectrum disorders through a clinic here at the University of Minnesota that has been running since the 1970s. And long predated me. And when I arrived as a trainee at the University of Minnesota, I first started seeing patients for neuropsych evaluations and found the population really interesting and one that was very much in need of research. There was very little research going on, especially in some of the things that I was interested in, like brain imaging. So we launched into studies back in the early 2000s and have been going strong ever since. And now in the last 15 years have really been interested in intervention studies in this population. So it's been a fascinating journey all these years, and I couldn't have asked for a more interesting area and a more grateful, varied, strong population of folks to work with.
I can imagine. But before we dig into that research, Blake, would you mind taking that question for you?
Yeah, absolutely. Thank you for that question. I think similarly to Jeff, I had very little experience with FASD until I actually came to the University of Minnesota myself to train. So there's a nice sort of generational effect there as well. So when I was there training in psychology, I had some experience working with Jeff in his clinic. I also had some experience working with a nonprofit here in Minnesota when I was in my training that really catered to working with families with children with FASD, Proof Alliance. And those experiences working clinically with families really were very, very meaningful for me. And I developed a real passion for helping families, helping understand development in that context. And that clinical experience really led to an interest in research. So applying sort of some of those insights and experiences in clinical settings to thinking about how we can use research to really improve the lives of kids with FASD. So that's sort of how I got involved with some of the studies that Jeff has been running at the University of Minnesota. Those are very exciting for me. I think there's a lot of really cool research happening in this field right now. And at this early stage of my career, I'm really excited to be a part of that and specifically to sort of focus on ways we can support development and understand how development unfolds over time in kids with FASD.
Definitely, definitely. And your passion really shot through. Me and Blake did record a video together. Blake, you presented in NOFASD 3-minute thesis competition last year, in which you summarized your research involvement really well in just 3 minutes. I know Jeff is the co-author of the research that was the center of that 3-minute thesis video. Blake, can you tell us more about your involvement in that particular research in evaluating Dr. Madison's web-based brain assessment tool? Can you explain it to our audience and tell us how this tool works and what makes it different from traditional neuropsychological assessments? Don't worry, this time there's no strict time limit, so please feel free to go over 3 minutes.
Great. Yeah, thank you for that question. And it was a privilege to present at the NOFASD conference a couple of years ago. I think it's a great conference that you all put on, and I really like how it brings together researchers and clinicians and people with lived experience of FASD. I think that's really, really valuable. So I was really happy to be a part of that. But the study you asked about specifically that we're going to talk about today, in addition to other topics that we'll talk about, this is a study, like you said, we're partnering with Sarah Matson's team. So she's down at San Diego State University in California. And she's developed a really innovative online tool that assesses things like thinking skills, attention, memory and learning, reaction time or processing speed. The idea there is that she's developing this tool to sort of screen for cognitive challenges that might come up for kids and adults with FASD. So I'll give you a little bit of background about the study that we're doing. So many families, many of the listeners of this podcast might have this experience of coming up across many different barriers when they're coming to try to find services for their child or for a family member. So for example, there's a lot of stigma, I know in the United States and also in Australia as well. There's very few providers who know how to diagnose and assess FASD. And there's really long wait lists for some of these services. And they vary quite a bit in our country in terms of where families can actually get care. And so some of those barriers, we've been trying to think about ways that we can use research to address some of those barriers. And the idea with this study is that we're trying to evaluate whether this tool might be useful in a diagnostic setting. What I mentioned earlier, again, is that really the goal is to kind of get that quick and efficient way of evaluating things like attention and learning skills. And in this study that we're doing right now, we're comparing how those scores from that online tool line up with more traditional neuropsychological assessment measures. So in this study, we're having kids at home. This is entirely an online study. We're having kids and teens with a history of alcohol exposure or FASD complete this online tool. And then we're also having their families send us an evaluation report that they had done in their community. So that's that sort of diagnostic evaluation that kids will have done through their community. And what we're doing is we're comparing the scores that we get from the online tool to the scores that we get in those neuropsych assessment reports. And our goal is really to see how well this tool might line up with some of those things that we look for in a typical diagnostic evaluation. We think that this type of approach might have a lot of value. It might help clinicians determine sort of what areas of thinking skills might need to be assessed in greater depth when kids come in for their evaluation. It might shorten wait times if clinicians can get a sense of who's coming in the door and what their needs might be. It could even possibly be used to sort of track development over time and response to interventions over time as well. So this is sort of an initial first step to get a sense of how this tool might be used and how it lines up with some of those more traditional measures that we might do that take a lot longer in the clinical setting.
Fascinating. Jeff, do you have anything you want to add to that?
Yeah, I would just say that this is not at this point meant to be a substitute for an in-person neuropsych evaluation. However, in the future, we might anticipate a time when a clinician, let's say located in an urban area, could use a tool like this to reach out to communities that are more distant or rural or isolated in some way to do this type of evaluation remotely. It's not, there are many people across the field of neuropsychology working on that very idea of doing remote neuropsychology to extend the reach of the clinicians. So this is a fantastic effort that's really focused on FASD, where we know there are high needs and where we know the diagnostic capacity is not anywhere near what it needs to be to meet the needs of the population.
It's interesting you should say that, because that really resonates with us in Australia, because it's a very vast country. It's it's a lot of people who are outside the major cities, the major areas out in the country. This tool could really be a boon for them in assisting them in terms of letting them know what the wait times and all that sort of things, and letting the clinicians know how great their need would be in that regard.
Yeah.
I'm going to direct this question first to Jeff, and then I'll ask Blake. But your research, which you're both co-authors on, you have made a use of brain imaging techniques like MRI. What kinds of structural or functional changes do you observe in individuals with FASD?
Mm-hmm. Great question. It's varied, and I would say that it's not something that we universally see. So we have looked at, hundreds of people with FASD over the years with brain imaging, and in some cases, there is nothing different about the brain that we can see physically. In many cases, that's true. We have used some advanced tools to really dig down to essentially the atomic level to get at some measures of the integrity of the structures that you can't visibly see with the eye, but you can still measure using the tools of the MRI. And so, for example, we have seen differences in the white matter in the brain. And the white matter is kind of the wiring that carries the signals over long distances across the brain. So it looks normal, but when we use these special MRI tools, we can see that there are differences at the microstructural level, or at the almost at the the detail level that's so fine that you can't see it, but you can still measure it using these tools. So that's one example that we do with imaging. And Blake has been working on some really interesting applications of large data sets characterize brain growth, just like a growth chart that a pediatrician would use in an office to see, is this child on track as far as their height or weight? Blake's been developing some techniques with brain imaging, and so he can probably talk a little bit about that.
Oh, please do, Blake. I'd be very interested to hear how you're kind of charting that growth and how that is kind of beneficial.
Yeah, exactly. So like Jeff mentioned, people listening might be familiar with this idea of growth charts. So if you went to your pediatrician, they might take your child's weight and height, for example, and chart it and see sort of how typical that metric is compared to expectations for the child's age and sex. And so we can, with these large data sets, tools have been developed to allow us to do this with the brain as well. So for example, we can take an individual's brain scan and we can quantify, in terms of things like brain size and brain volume, how typical or atypical that is compared to developmental expectations. And that sort of degree of variability we are finding has a lot of value in explaining sort of what some of the kind of challenges that we see in these kids. So for example, kids who have greater deviations in those brain growth metrics are we're finding have greater challenges. And we're also kind of exploring the way that these tools might be used to potentially in the future supplement some of our current diagnostic sort of ways of thinking about FASD. So for example, many diagnostic systems for FASD use head size as sort of an estimation of brain volume differences. But what we know is that after a certain age, brain size and head size don't line up perfectly. So we might have, individuals who have normal head sizes, but actually have smaller brain sizes than developmental expectations. And so what we're finding is we're using these tools to sort of look at how well that actual brain volume compares to the head size. And what we find is that the brain volume itself might actually be more accurate in identifying those developmental differences in some kids with FASD versus that sort of overall head size measurement. So that's just one way that we're sort of using this tool and thinking about these tools and ways they might be useful in understanding FASD and potentially identifying developmental differences in some kids.
That's really interesting. My next question was going to be, how do those kind of brain differences translate into behavioral or learning challenges? But I think you've already kind of answered that a bit there in terms of that. Is there any other way that, we can, understand these brain differences and you translate them into how but these kind of behavior, to explain these, a child may have challenges in behavioral or learning in terms of that? Or is it too, would you say it's too early?
I think that's a great question. So like, oh, did you want to answer that, Jeff?
No, no, go ahead.
Well, I was gonna add to what something Jeff said earlier, which is that for some kids we don't see these differences in structure of the brain, whereas even in the context of some of these behavioral challenges that we see. So I think the aim of this research using brain imaging is to sort of understand group differences as one way of sort of explaining some of these behavioral challenges. So when we look at kids with FASD versus kids who are unexposed or typically developing, we're able to see potentially some differences in the structure of the brain at a single point in time. We're also interested in looking at change over time. So that's another area of research that we've been exploring is sort of how brain changes occur across development and how those changes themselves rather than sort of the single one time point differences might actually explain some of these behavioral challenges in some kids. So it's a couple of different ways that we're kind of thinking about this.
Interesting. Jeff, is there anything you wanted to add to that?
Sure. I would just say that there are situations where we look at the brain imaging data in a group and we can see a clear relationship between, let's say, the size of a structure and a behavior, or let's say intelligence is one of our kind of overall measures of cognitive functioning that does seem to correlate with some aspects of brain size. And that tells us, not surprisingly, that the amount of effect that alcohol has had on the brain in terms of growth relates to the ultimate cognitive functioning of that individual. And it's not just the amount of alcohol, but it's the timing of the alcohol exposure. It's other factors related to the parent and the baby's genetics. It's, nutrition. But the effect on the brain of that early exposure does indeed translate to an outcome that we can measure with intelligence tests, memory tests, attention, those types of things. It's not a one-to-one with the brain, but in a overall sense, we do see those relationships. Yeah.
How much does genetic factors play in those kind of brain differences?
Well, we know for sure that there is a genetic component to things like intelligence and even attention. So, for example, the most common form of attention problem, attention deficit hyperactivity disorder, has a strong genetic component to it. So we know that the genes have something to do with how the brain is built, how the brain functions, even without alcohol in the mix. When you put alcohol into the mix and you have genetics, then you have an interaction, and that makes it more complicated to know what the outcome is going to be from something like prenatal alcohol exposure because it's just one factor, right?
I know that you've been researching the topic of choline for many years now. Can you walk us through the research findings on choline supplementation and its potential benefits for individuals with FASD?
Sure. Yeah, we've been studying choline now for about 15 years, maybe a little bit longer than 15 years. And choline is a single nutrient. It's in the diet. We eat choline when we consume animal products, especially, but also some vegetable products. But oftentimes, the amount of choline that someone takes in is not totally sufficient, depending on their diet. During pregnancy, choline is even more important because it is a nutrient that's essential for brain development. So, mom actually needs to eat more choline during pregnancy than she would otherwise in order to supply herself and the developing baby. So, we know it's a super important nutrient for brain development. Without it, in studies that are, you have animals who are deprived of choline, you see changes in the brain that result in very significant structural problems and functional problems for the brain. So, a number of years prior to my starting working on choline, some investigators, including Jennifer Thomas and others, started testing whether choline could be an optimizer in rodents who were given alcohol prenatally. So they wanted to see if they could essentially reverse some of the damage from the alcohol by giving choline either prenatally during the pregnancy or even postnatally after the rodents were born. And they showed a number of different effects, beneficial effects in those animal models. So we took that approach in humans for the first time back in, about 15 years ago. And really, we're targeting a need of developing kids who don't get identified until they're 2, 3, 4, 5 years old. We're looking for an opportunity to optimize their development going forward. And choline, since it's important in brain development, was a good candidate for that. So we started administering it in randomized controlled trials, which is the best way to test whether something can be an effective treatment, is to randomize people. Nobody knows who's receiving what until after the fact. And you measure as carefully as you can things like memory, performance before and after. And these are complex studies to do. The study that we did was a 9-month study. So the kids, the 2 to 5 year olds, were on choline for 9 months. And the first study we did took 2 years. The next one took 3 years. And then we did a 5-year study after that and another 5-year study. So what we've learned from this is that, yes, we can detect some benefits in humans, especially in the area of memory in kids who have had prenatal alcohol exposure. And it's not an earth-shattering effect. It doesn't completely reverse all of the effects of alcohol, but it's measurable. And something measurable in humans over a long span of development like that is pretty intriguing and pretty important for the field, even though it's a small effect, because development is additive. And if you start early with an intervention and you have an effect, let's say in a 2-year-old or a 3-year-old, everything that comes after that builds on top of that effect that you've created at 2 or 3. That's the idea here, is to take a normal developmental process, which is kind of like a heavy vehicle going down the road or a ship traveling down the ocean, and you nudge it in one direction, and then it continues on that path and kind of magnifies the effect over time. So we're pretty excited about the fact that we've been able to detect these effects, that, this is a safe, fairly innocuous kind of intervention. It's even something that people can correct in the diet and not necessarily need to do supplementation if they just increase the amount of choline in the diet. So it's a very scalable, useful kind of intervention. The one thing that I always am careful to state when I talk about this is that we think it's most effective under the age of 4, probably. And there are other investigators studying this prenatally. There, it's probably very effective in when the child is a fetus. And when we do this in 2 and 3-year-olds, we really see the effect there. So it's not an intervention that we expect to work with adults, not even necessarily with adolescents, but really more of a preschool age kind of intervention.
From what you've said, I'm guessing the best window of opportunity for choline supplementation is the younger the better in terms of that as a intervention window.
Right. And again, prenatally would be best. So that would be if you can get to the mom when she acknowledges that there has been alcohol exposure, give the choline to mom, it gets transmitted to the fetus, and that is where you're going to have probably the most effect. But we've done all of our work in the 2 to 5-year-old age range, so that's where we know we've seen benefits, especially in the 2 and 3-year-olds.
Fascinating. Blake, is there anything, I'm not sure how much you've been aware of this study, or this must be interesting to you though, you're kind of being in the same kind of field. You got any comments?
Yeah. I think it's a fascinating line of research, and really, really meaningful research that has a big impact on a lot of families. People have asked us a lot of questions about choline. It's something that I think families are thinking about when they're raising kids with FASD. I'll mention too that this ongoing work has looked at long-term outcomes in these kids as well. So Jeff's team, and I was involved in some of this work when I was a trainee at the University of Minnesota, looking at long-term outcomes at, for example, the 4-year mark after that intervention trial and at the 7-year mark. And so one of the studies that I was involved in when I was there was that 7-year time point where we brought back kids who had received the choline treatment or the placebo, and we looked at things like thinking skills, and we also took a brain scan to see sort of if we see differences in the brain, even at that long-term follow-up point. And what we find is that those benefits in cognition seem to become more and more noticeable as kids age. So Jeff was kind of mentioning that compounding effect of development, where those foundational years of brain development really play a big role in later development across the lifespan. So that was really exciting to me to be a part of that work, to see sort of that those benefits might actually become more noticeable and more impactful as kids get older. Another thing we saw is that when we looked at the brain scans, we saw that there were differences in the brains of kids who received the choline versus those who received the placebo. And specifically, Jeff was talking a little bit about this, the white matter in the brain. So this is something that we see is often impacted in kids with FASD. And choline might play a role in supporting the development of that important brain type of tissue in the brain. And what we saw at that long-term follow-up point, at the 7-year follow-up point, is that the kids who received choline had sort of more typical structure of the white matter in a really important part of the brain that connects both sides of the brain. It's called the corpus callosum. And so that was really exciting to us that, this is not a causal relationship that we can make at this point, but might play a role in some of the benefits that we see at that long-term follow-up point, that, we might see a benefit for things like white matter early in life that really plays out even into the childhood and teenage years in some of these kids. And so that was really exciting for me to be a part of that work. And I think it's exciting to see that the work continue and continue to follow those kids over time.
Oh, it's very exciting research. I know when we put it on our social media here, it garnered a lot of interest in parents and caregivers, in terms of memory, because that is a big aspect. And childhood and teenagers, it's a very critical period in a human being's life, that you're gaining a lot in terms of school, and memory does play a huge factor in terms of learning, and especially in the models how we teach in the Western world in terms of memorizing stuff and all that. So that plays a very key aspect. Jeff, are there any other supplements that would benefit a person with FASD?
Yeah, it's a very good question. There have been some other investigators who are interested in some fatty acids, DHA being one of those, and they have looked at these in animal models. I'm not aware of any human studies that have yet tested whether DHA could be used in a similar way that we've used choline in FASD. But that's out there on the horizon for researchers. There are other nutrients that researchers are investigating, and I think there is a general understanding that the whole nutritional package that a child is exposed to is really critical for brain development. So, for people who want to think about nutrition, it's probably a good idea to think about overall nutrition, making sure the caloric intake is good for the child, making sure that, it's a balanced diet and that the micronutrients are all kind of in the range that you would want. These are things you can look up or you can get out of an app looking at nutrition. But so far, choline is really the one where we have the evidence. It's been studied prenatally and also in kids. And that's really been the translation from the animal work to the human work. So that's the one that we're kind of the most confident in right now.
This is a question I'm going to ask you both. But can you talk about any recent breakthroughs or surprising findings you've made correlating brain development and cognitive outcomes in FASD? Blake, did you want to handle this question first?
Sure. Yeah. So we've been exploring a couple of different avenues recently that I'm really excited about. So one is, we talked earlier about some of the imaging studies that we've been involved in, looking at things like white matter and brain volumes. More recently, one of the areas of the brain that we've become more interested in is the cerebellum. So this is a part of the back of the brain that plays a really important role, traditionally thought to play a really important role in things like motor coordination and balance. But really, we're learning more and more from other researchers that it plays a really big role in things like thinking skills, attention, emotion regulation. And some of the earliest studies of FASD showed the differences in this part of the brain as one of the key findings in some of those early imaging research programs. And so we've been starting to explore this idea of looking at the cerebellum in a lot of detail. So one of the studies that we're currently under review for looked at the cerebellum in a lot of detail. And what we found is that volume differences, kids with FASD show these volume differences in parts of that cerebellum play a really big role in things like attention and learning. And what we found when we looked at sort of the relationship of those cerebellum differences to cognitive performance in our sample, we do find those relationships as well, where kids who have more atypical cerebellum structure do tend to have more of those cognitive challenges. So that was really exciting to me. I think it's an area that there could be a lot more research. And I think it's an area that we don't necessarily think about as much when we think about FASD. We typically think about things like the cortex and the white matter. So that was really exciting to me to be a part of that work.
Definitely, definitely. Because, yeah, a lot of that research is focused on that front part of the brain rather than the cerebellum, which is, it's interesting that it's also kind of wound up in all this. Jeff, same question to you.
Maybe I'll just say that some of the approaches that Blake has been taking, again with large data sets, to really home in on what's normal, what's typical for a given age, and what we see in FASD, that is super helpful to us to understand sort of where on the developmental curve that individual may be, or a group may be. That gives us clear guidance for interventions. If we recognize, for example, that some part of brain development is a year delayed on average, or maybe eventually we'll be able to say, here's an individual who has this type of an alteration in their brain development. How do we design a teaching strategy for that person based on now that we know they're 2 years behind in their development of this structure in the brain, or that structure of the brain, may not recover to the to the extent that we want it to. How do we design a teaching strategy or a behavioral intervention that's really recognizing that specific thing about the individual or the population? I think that's an advancement, and Blake has been really taking advantage of these large publicly available data sets to do that kind of unique work.
A huge advancement, especially in the role of teaching, because a lot of these kids kind of go through school with FASD, and some of them are unrecognized, and some of them who are recognized find it even more difficult to go through mainstream school. I'm going to direct this one at Jeff before asking Blake, but what other FASD related studies are you currently working on, and what are you hoping to discover?
Well, we're working on neuromodulation, which is a fancy way of saying stimulating the brain with electricity. So this is an application that we think could extend beyond the other time period that I was talking about for choline, for example, which is preschool, let's say under 4 or 5. Here with neuromodulation, where we can stimulate different parts of the brain, this is a type of intervention that could be used in any age, and we're testing it in the 8 to 16-year-old age range, so kind of school age and adolescence, high school age. And that is paired with cognitive training. When the reason that we do that pairing of electrical stimulation to the brain and cognitive training, or practicing certain skills like memory skills or problem solving skills, is because the electricity kind of wakes up the cells a little bit. It lowers the threshold for the brain cells to fire just a little bit. And then when you're stimulating those parts of the brain with these exercises or brain games, it's that pairing of the change in the stimulation threshold or firing threshold and the cognitive work that the person is doing that then gets strengthened in the brain. And there's a saying in neuroscience that cells that fire together wire together, meaning that when you are using certain parts of the brain together, those are the ones that are going to get linked and are going to stick with you as a problem-solving approach or a memory or something that you can build on later. So that's a concept that we're testing in randomized controlled trials now. We've been working on this for a while, and we've had some good results, and we're now testing a completely remote apparatus where we can have someone in their home and they can put a cap on and we can stimulate different parts of the brain while they're doing this cognitive training. So again, the idea is to try to reach people in a way that they don't all have to come to academic centers in major urban areas. And we want to extend the age range that we can apply treatments to in this case.
Fascinating. That would be incredible if something was like rolled out internationally. I mean, I imagine it will eventually once you've completed all the research, but it would be a major breakthrough in terms of, education, learning, waking up those portions of the brain that might not necessarily be able to use it. Yeah, it's interesting. Blake, same question. Is there anything you want to add on to what you've been saying before?
Yeah, so we talked about that study that's ongoing, looking at that online tool, Brain Online. Another study that I've been involved in here at Nationwide here in Ohio. So I've continued to be involved with Jeff's team, but I'm really sort of trying to start a line of research in FASD here as well. And so one project I'm working on right now is using a very large national data set to look at modifiable factors that might impact cognitive function in kids with a history of alcohol exposure. So this is a non-clinical sample, it's a community sample, and it's data from a number of different sites across the United States, where researchers collected detailed data on pregnancy factors, maternal health, and child development sort of across the lifespan. Yeah, so this is a really rich data set where we're working with this national sample, and specifically we're looking at the role of sleep in cognitive outcomes in kids with a history of alcohol exposure. So we're not collecting any data. This is a historically collected data set, but we're looking at how kids with alcohol exposure, how they might experience challenges with sleep. So things like impaired sleep quality, nightmares, difficulties initiating and maintaining sleep, and sort of how parents rate these behaviors in their children. And we're looking at how those differences in sleep quality might relate to things like attention and learning and executive function. So we think this is a really valuable approach that could provide information that is helpful for people working with families with FASD, potentially useful for clinical work, so recommendations that clinicians can provide families in terms of supporting sleep. And the benefit of this data set is that it's very large. So we have a lot more statistical power than we do in a typical study where we might collect 30 or 40 kids in each group. So this is a really interesting, I think, approach that could sort of help understand some of the risk and sort of resilience factors that might relate to cognitive outcomes in terms of a history of alcohol exposure.
Very interesting and very invaluable as well. I mentioned that must be a huge data set because I've talked to a number of people with FASD, and a lot of them have issues with sleep. A lot of them, it's a very noticeable symptom of FASD where sleeping issues is very much an aspect for a lot of people. I've talked to a number of parents and carers as well who say that's very much an issue with their child. So that would be invaluable. I imagine that must be a very huge data set.
Yeah, I think it's a really interesting area. Like you said, there's a lot of families who work with described sleep issues in children with FASD, and there's a growing research interest within the field to look at how sleep might play a role. So, for example, some of our colleagues have looked at clock genes. So these are genes within the body that regulate these diurnal cycles and regulate things like sleep throughout the day, and they find that they can be impacted by alcohol exposure, and we might relate to some of the things that we see in kids and teens with FASD where it's hard to maintain sleep, or sleep is often fragmented, and that can play a really big role in things like thinking skills and attention during the day. So this, I think, is a valuable sort of area to hone in on and understand better.
Completely. All right. So my last question for the interview is for parents and caregivers who might be listening, what's one of the key message you'd like them to take away from your research? Blake, I'll ask you this question first, and then I'll move on to Jeff, if that's okay.
Yeah, I think one thing that comes to mind is really to sort of focus on the hope, right? I think a lot of the research that's out there has focused on challenges with kids with FASD, and sort of what might be driving some of those challenges. We've talked about some of that research today, for example, the neuroimaging work. But importantly, this isn't the whole story. That there's actually more and more research showing nowadays that individuals with FASD have a lot of unique strengths and a lot of unique talents. And there's a lot of great resources out there for families with kids with FASD. I think getting connected with other families, parenting kids with FASD can be really valuable for a lot of families. And sure, there's a lot of work to be done. So I think at this point, there's very few interventions that have been developed for kids with FASD. We talked about one, choline as a supplementation for young kids. But I think we're at a point now where we're really making a lot of really important gains in research and identifying potential avenues for intervention. And some of these interventions that we're thinking about could have a really big impact, both in childhood and also across the lifespan. And so I think the opportunity to be a part of that innovative work and bringing people together across many different areas of research, people that are involved in genetics and nutrition and imaging and psychology, I think it's a really exciting time for researchers and clinicians to get involved in this work and also for families to be a part of it as well. So that's something that is really exciting for me and really motivates a lot of my interest in my work as well.
Well, it's very exciting for me too, as someone outside the research circle, but very interested to hear what you guys are doing. Jeff, same question. What is the key message you'd like people to take away from your research?
Yeah, I love Blake's message of hope. I agree. I think, it's very important to realize that development is an ongoing process, and it's an energetic process that takes place regardless of anything else we do. Development continues, and nudging that development here and there can have big effects, and that even when you have a difficult start due to, let's say, an insult like prenatal alcohol exposure, there's still many, many opportunities to intervene. We as researchers and clinicians, we listen to parents. Moms and dads know a lot about child behavior and a lot about child learning and a lot about the emotional needs of kids with special conditions like FASD. So we're tremendously encouraging of parents being involved in research. We love having families participate. I encourage folks to participate in whatever the way they can, take surveys, join studies that you can do remotely, connect up with your local university if they're doing research on FASD, be part of the process. And that's empowering, as Blake said, being a contributor empowers you to kind of take charge over the things that you might be struggling with. And it also connects you to a network of people, which is now very global, as you can see. We're crossing, many, many time zones here right now. Join this movement of connecting people with FASDs and others who care about them and who want to move the field forward.
Definitely. I couldn't agree more with that statement, Jeff. I think clearly from this interview, we have a pair of very enthusiastic, intelligent researchers, and there are many more out there, and I can't wait to see what you guys do next, to be honest. I'm sitting here waiting, all excited. I'm sure my listeners are too. So I wanted to thank you so much for coming on today and chatting with me. And I hope you enjoyed the process too.
This has been great, Kurt. Thank you so much.
Yeah, thank you, Kurt. Really appreciate it.
Thank you for listening to this episode of Pregnancy, Alcohol, and FASD, The Surprising Reality. If you like this podcast episode, please show your support by leaving a rating and review on iTunes. We appreciate your feedback. All rights reserved. For more information about fetal alcohol spectrum disorder, please visit NOFASD Australia's website, www.nofasd.org.au.